Hi, this is Mrs. Slater, and today we're talking about equations in 3 variables. So instead of two answers, we're going to get 3 answers, and the solution is called an ordered triple instead of an ordered pair. Also, your answer will look like the following. There will be an x value, a y value, and a z value, or ABC, or PDQ. But definitely know that there's going to be 3 answers. So this is what I would like to write down for the steps. How to solve a linear combination. Okay, we're going to eliminate a variable in 2 equations. Then we're going to eliminate the same variable in 2 different equations. Then we're going to take steps 1 and 2, because they're going to result in 2 equations with 2 variables. And then finish with elimination and substitution method. Push pause if needed. Alright, so for the first example, it looks like this. Okay, right now I already see that the z's can eliminate if I put those 2 together. So I'm going to take these 2 equations and rewrite them. I'm going to call them 1, 2, and 3. So above here I'm going to say that I'm using equation 1 and equation 2. Again, this is all just to keep organized because it gets pretty long on these problems. Okay, when you add them together, you get 3x minus 2y. Z's are going to cancel, 7. Okay, so now what we have to do is figure out 2 different equations, and I'm going to pick the second one and the third one. Equation 2 and equation 3. Again, just to keep organized, and you can see they're 2 different ones. I'm going to rewrite them below. 2x plus y minus z equals 5, and x plus 4y plus 3z equals 13. Okay, and by elimination method, I can multiply the top one by 3 in order to get a cancellation. So that would be 6x plus 3y minus 3z equals 15. Now notice I am picking the same exact variable to eliminate. That is a very, very important part of this process. So when I add these 2 together, I end up with 7x plus 7y equals 28. Okay, now let's look at the results of both of them. Here you have 2 equations with 2 variables, and those variables are exactly the same variables. So we'll be able to solve for x and y. So by combining the 2 of them, I get 3x minus 2y equals 7, and 7x plus 7y equals 28. Okay, now by elimination method, I can multiply the top one by 7 and the bottom one by 2 in order to get the y's to cancel. At this point, it won't matter if you want to cancel the x's or the y's. If I multiply that through, I get 21x minus 14y equals 49. And then on the bottom, I have 14x plus 14y equals 56. And then when I add those together, I get 35x equals 15. Carry that to get 105. So x is going to equal 3. Okay, so now what to do is we have to find 3. We're going to take the 3 and replace it in one of the 2 examples here. So we have 3 times 3 minus 2y equals 7. 9 minus 2y equals 7. And negative 2y equals a negative 2. Y equals 1. So we have 1 left over, and we will have to take both x equals 3 and 1 and go all the way to the top and pick one of the 2 equations up here. I'm going to choose the first one. Again, it does not matter. I'm going to put x minus 3y plus z equals 2, and I'm going to replace what I know. 3 minus 3 times 1 plus z equals 2. And we have 3 minus 3 plus z equals 2. That ends up canceling each other out, so z equals 2. Now when you write your final answer, it's going to be an ordered triple. 3, 1, and 2 is your solution. That is where all of those lines meet. Okay, so we're going to have to practice this some more. I have another one ready for you to go. And choose the most convenient way to eliminate x's. And since x is all by itself here, that's going to make me want to eliminate the x's. And that will save you some steps along the way. So here's the first equation, the second equation, and the third equation. We're going to use the first one, equation 1, and equation 2, and then I'm also going to use equation 1 with equation 3, because that is going to help with the elimination method. So x plus 2y plus 3z equals 6, 3x plus 7y plus 11z equals 22. And if I multiply the top by a negative 3, then I'll be able to eliminate the x's. So that would be a negative 3x minus 6y minus 9z equals a negative 18. Double check to make sure you multiplied negative 3 by everything, and then we'll add the two equations together. So y plus 2z equals 4. Okay, we'll come back to that in a little bit. Now let's do equation 1 and equation 3. Those are x plus 2y plus 3z equals 6, and equation 3 is 5x plus 12y plus 48z equals 125. And if I multiply the top by negative 5, again, we're trying to eliminate x, so we have to multiply the top. We end up with negative 5x minus 10y minus 15z equals a negative 30. Now I'm going to add those two equations together. 2y minus 33z equals 95. Okay, so now the two things in the rectangles, we're going to put them together. Again, notice that we have two variables, two equations, and we'll be able to solve by elimination or substitution. Okay, so we're going to combine these together to get y plus 2z equals 4, and 2y minus 33z equals 95. And it looks like a negative 2 multiplied by that first equation is going to help us out here. So I'm going to multiply that negative 2y minus 4z equals a negative 8. Double check to make sure you got your negatives. And then we're going to add these two equations together. So we end up with negative 37z equals... Okay, so it looks like I've made a mistake, so erase that. You may have already found it already. But if you go back to the green right here, 48 minus 15 is not a negative 33, but it is a positive. So I want to make that change before I do anything else. And that's going to make 33 minus 4, 29z, and then 95 minus 8 is 87, which is going to give me 3 for an answer. Alright, so z is at the end, so that's where I'm going to put in my order triple. Okay, so now I'm going to take z equaling 3 and replace it into one of the previous problems. So we have y plus 2z equals 4, and I know that 2 times 3 equals 6. And if I subtract that, I'll get a negative 2, and that's going to go in the second place for my ordered triple. And then finally, I'm going to take 3 and negative 2 and plug it back into my original. And I'm going to choose the first one, x plus 2y plus 3z equals 6. And we do not know x, so that's going to be left alone. 2 times negative 2 plus 3 times 3 equals 6. X minus 4 plus 9. We'll end up with 5 on this side, so if we subtract 5 from both sides, we get x equals 1. So that's going to complete my order triple. That is where all 3 lines are going to meet. Next, I want you to know also how to do these in the graphing calculator. It is with several steps. So I want you to go ahead and write this down. The first step is we're going to go to matrix, and as we've already been there before, it's second and then a to the negative x. Some of yours are different. You may have a matrix button all to itself. Okay, and then in edit we're going to make a 3 by 4 matrix, and you can push enter after 3 and enter after 4. The next one, we're going to enter the values of each equation, and then we're going to quit. That's very important that you quit, because it will mess things up if you don't. Go back into matrix, and then to math. B, like the actual letter, it's not 1, 2, 3, 4, 5, but it gets into A and B. So REF, it's called reduced row echelon form. And then go back into matrix and names. Make sure you're on the matrix that you have entered. We'll go through this on the calculator. The last column is going to be your answer. Okay, so after you write those down, push pause if you need to, then we're going to check one of our previous examples. Okay, so the second example we're going to plug in. Go to matrix, so second, a to the negative 1, and we're going to go to edit. Okay, and then under edit, we're going to push enter. And here's where you're going to put, if you have something else there besides 1, 1, just override it with a 3, enter, 4, enter. And we're going to put in the coefficients only. So 1, enter, 2, enter, 3, enter, 6, enter. And then you start the process over again. 3, 7, 11, 22, and the last one is 5, 12, 48, 125. Okay, so we are going to have to quit. So second quit is above mode, and then we'll go back into matrix. Oops. Okay, now I'm back into matrix, and I'm going to go to math, and I'm going to choose to go up instead because I get there a little faster. So you can see at B, RREF, push enter, and then we're going to go back into matrix and then grab A. So A, that's what your screen should look like, and then when you push enter, notice that your answer, and if I go to my answer, what I previously got, oops, yeah, there we go, compare the two of them, you will see that that last column is a match to our order triple. So 1, -2, and 3 are the answers, and we have just learned how to do it on the calculator. Okay, so that is it for today.